Live 2. Welcome to the stream pre-chat, everyone.
Yes. Gonna send out a tweet.
I'm lazy. I'll just retweet whatever you tweet.
Hey, Redwood Coast. Yeah, we only had to reboot twice this morning, didn't we?
Yeah, one each, I believe.
Yeah, one each. You had to reboot because OBS was crashing. I had to reboot because my microphone wouldn't work. I also forgot my kid's backpack taking him to school. So I was crossing the road on the way into the playground and just looked at my kid's back and was like, something is missing. Hey, Oliver. So I had to drop my kids, watch him get inside safely, run back home, pick up the backpack, run back to school, and then hand it in at the office.
I'm glad you don't live 45 minutes away.
Yeah, geez, yeah, it's quite nice. It's like 10-minute walk or something from my house to my kid's school. So
you did that quickly because 10 minutes after you texted me oh shit, I forgot my backpack or the backpack, you were back on stream, so you sprinted.
Yeah, when I say I ran back to the school with the backpack, I mean I ran. Yeah.
Amazing. By the way, what was it about your kitchen being on fire yesterday?
Oh yeah, so yesterday just everything went wrong. It was one of those days where just anything which could go wrong went wrong, and I made dinner and then I ate dinner and I went back through to the kitchen because my kid wanted a glass of water or something, and just saw that the hob was still on and something was on fire. I was like, well, that's not good, I'll get something. And then I realized that the thing that was on fire was a plastic lighter, and I was like, this thing could explode. So I grabbed the tea towel, drenched it in water as fast as I possibly could, just lobbed it at the flaming lighter, and managed to put it out. But yeah, one of those moments where just your whole body goes into panic mode. That was one of those moments.
That's the perfect ending to a terrible day.
It really was. To be fair, after that, I went and lay down and screwed around on Twitter and then fell asleep and then woke up and felt a little bit better after that.
Yeah, I'm glad your house was still there when you woke up as well.
Yes, me too. Jeez.
Yeah.
Hey, Russ, how's it going?
I got woken up this morning at 7 a.m. by Nori being like, where's my food? Give me food. So I go into the kitchen, give her a can of food, and she's like, I don't like that food. I'm like, oh God,
no. My kid is taken to waking up at 6 and going to play Roblox on his own and letting us sleep a little bit, which is actually I'm fine with that.
Amazing. Hey, Rusk. How's it going?
Hey, Walter. Good morning, as they do indeed say. Oh, in fact, I have a cat right next to me. I wonder if I can. I'm just checking my room to see if I have anything that I shouldn't put on camera, but I don't think there is. I have Lexical cat sitting down here.
Aww.
in her little basket. She does love just sitting next to me while I work. Don't you? Yes.
No.
She's a very sweet cat.
Such a
All right, we're at half past. Should we get started?
That sounds like a good idea. I think we promised we'd do some Advent of Code. So let's...
Yeah. All right, day 3, binary diagnostic. Oh, I'm liking the sound of this already. The submarine has been making some odd creaking noises, so you ask it to produce a diagnostic report just in case. The diagnostic report consists of a list of binary numbers, good, like this, which when decoded properly can tell you many useful things about the conditions of the submarine. The first parameter to check is the power consumption. Mm-hmm. You need to use the binary numbers in the diagnostic report to generate 2 new binary numbers called the gamma rate and the epsilon rate. The power consumption can then be found by multiplying the gamma rate by the epsilon rate. Each bit in the gamma rate can be determined by finding the most common bit in the corresponding position of all numbers in the diagnostic report. So given a large list of binary numbers, considering only the first bit of each number, do they mean the rightmost or the leftmost? there are 5 0 bits. Yeah. There are 5 0 bits and 7 1 bits. Since the most common bit is 1, the first bit of the gamma rate is 1. Okay. Then, yeah, same again.
Gamma rate and epsilon rate sound suspiciously much like, what is it? Watts and volts? Or the other one? Full volts?
Yeah. So that's the gamma rate. And then the epsilon rate is similar, but it's the least common bit. So just be taking the complement, assuming that it is like at least 32-bit. No, these are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12-bit numbers. Phenomenal. Okay, so that's fine. All right, so this seems reasonable. You happy with this, Josh? I think we're just going to be like going through each number, summing up the occurrences in each position, checking if the occurrences are greater than half of the number of binary numbers we have, and then generating a new number based on that.
I have a feeling this is going to take me a sec because I'm like half understanding like what's going on.
Sorry.
All right.
Okay.
I'll dig in.
Mute Josh.
Oh, you're going to mute me? You're not waiting for me to mute myself? I see. Well, muting. All right, everyone. Let's attempt this. I've like, again, half understood what's going on. Oh, whoops. That's 2 VS Code instances. But, you know, as usual, we can probably figure something out. So let's do what we usually do and just create the testing stuff and then work from there. And little by little, work away at the problem. Hey, Nero. Welcome. Glad you're here. Hey, day3.rs. We're going to add that here. Day3 run. Mod day3. And then in day3, as usual, pubfn run, which does nothing. CFG test. Mod test. Good morning, Kadu Benson. That's a cool name. Use super, and then test first, like that. Then we can run this, which does nothing, and that's great. All right. Hey, good morning, people. All right. Oh, wait, hold on. I need to move my terminal over a little bit so people can see better. Can I get this like that? Yes, that is visible. I also realized that for like replays, I should have Twitch chat in here somewhere. But maybe tomorrow. I'll fix it tomorrow, not today. All right. Okay. So test input here. We're just going through the motions now. Const input answer equals paste. Oh, we're not on the latest Rust version, but we're on nightly anyway, so that's all fine. Oh. Not sure what happened there, but okay. That was funny. Thanks for flagging that. Okay, let's see. Okay, size cinematic widescreen tartan lava. Yes, exactly. Amazing. I'm not sure what happened. I really don't know. I probably should deselect stuff in OBS. All right, there we go. Hopefully. Thanks, chat. Yes. All right. Perfect. All right, so the first example is we're gonna do a parsey of sorts. Let's say this returns usize, and then we say assert eq parse one. Oh, hold on, this doesn't return usize. Pubfn parse one usize, and this takes s and stir. You could boilerplate this, it'd be faster, but yeah. Input, and then the output is 198, right? Mismatch types, okay, and then this needs a to-do. Ta-da. All right. So what is it that we need to do? Oh, first off, we're parsing lines of sorts, so we likely need to do dot lines. For line s dot lines, and then it says, okay, submarine's been making creaky noises. Diagnostic report lists of binary numbers, which, when decoded properly, can tell you many useful things about the condition of the submarine. The first parameter is to check the power consumption. So, two new binary numbers called the gamma rate and the epsilon rate. The power consumption can be found by multiplying the gamma rate by the epsilon rate. Okay, each bit in the gamma rate can be determined by finding the most common bit in the corresponding position of all numbers in a diagnostic report. The most common bit in the corresponding position. Oh, so we just do like a top to bottom comparison, is that right? There are 5 0 bits and 7 1 bits. Is 1. The first bit of the gamma rate is 1. Oh, interesting. Oh, this is bit twiddling stuff. All right, I finally understand. Third, fourth, and fifth bits is 1, 1, and 0. So the final 3 bits of gamma rate are 1, 1, 0. Okay. 22 in decimal. The least common bit from each position is used. So that, all right. So once we have the most common bit, what we know is we can just inverse NOT it. Because if this produces 1, 0, 1, 1, 0, that's 22 in decimal. Then this is the exact inverse, 0, 1, 0, 0, 1, which is like a binary NOT, right? Which is 9, and then we multiply it 2. So we just need to like mask it like once. Now the question is, how do you do that? Maybe I should ask Sai for help, or if someone in chat like knows. I feel like I should ask Sai. Hey, Sai.
Yeah, go ahead.
Hey. All right, so I finally understood the problem. And I guess I wanted to ask, like, how are you planning to solve this? Like, what's your approach? Because it feels like bit twiddling, but I don't know what the bit twiddling operation here is.
So that's the thing. I don't think there's a really nice bit twiddly way to do this. My approach is just to have a vector of counts, loop through all the lines and the characters, count how many ones are in each position. Then with that vector, go through all of those counts, translate that to either a 1 or a 0, and then do a reduction to generate the binary number at the end.
Oh, I see. Okay. That's a bummer. Okay. Yes.
If you come up with a nice bit twiddly way to do it, please let me know.
Yeah, I was like wondering if we could like do a progressively increasing mask or something, and then like binary end it.
I was trying to think that as well, but
I'm not confident in my you know, bit twiddly ways to but I might try it. Anyway, yeah. Thanks for answering.
Cool.
I'll give it a shot. Boomerang saying at the end you can parse the number with base 2, I think, and yeah, that is indeed right. We like Rust even has like is even, I believe, is even. I think I added that. Oh. No, it's trailing zeros. Hell yeah. Returns the number of trailing zeros. We have like count once. Oh, I guess like what we could do is we could like keep doing like a rotation, where we can essentially like do yeah. Hold on. So solution. If you think of like any number in binary as just ones and zeros, right? Like a vec of one or zero, then you can do count leading ones or leading zeros, and essentially see like, are there any or aren't there any? And it should give you an indication of like what the first number is. That does mask, and then we can like rotate it like by one, so that the next one becomes the first one, and then you just keep flipping through, and then you will know that. Yeah, that will be nicer than doing a vec. Also more annoying. But I'm kind of down for it. Let's see if we can like make this work. Step one though is like to do an integer, binary parse. I forget how to do like binary parse. I believe there's like from binary or something. Binary parse binary. No. Let's just Google it. Rust parse binary number. Idiomatic way to parse stuff. Yeah. Oh, can we do like read binary digits from an integer in Rust? Okay. Std bit set. That's not Rust. Oh no, that's just printing. We don't have parsing, do we? String to binary string, convert a string to int. From stir int. No, also no. That's like string parse. Convert string to integer. Perl tooling. I don't want to import a crate. Reader, read. No, I don't like any of these solutions. I don't tend to like, you know, parse binary. Okay, let's figure it out. Because like the regular parse implementation just doesn't. We would get like the proper like full number. Oh, from stir radix. There we go. Yes. Thank you. I have used this before, actually. Yeah, no, perfect. Yes. Thank you. Thanks, Boomerang. And sometimes, like, when I'm like streaming like this, I'm like, oh yeah, I swear I've like written Rust before. It's just, you know, first thing in the morning, brain is not here. Yep. So that is let num equals where's from stir radix? From stir radix, and I think a U8. Let's do U16. Yeah, U16. Converts a string slice in a given base to an integer. Yeah, that makes sense. So binary is base 2, right? U16 from stir radix line, and then here we say base 2. Run test, sure. Hey, what did we print? Invalid digit, kind empty. Oh, none of that's good. None of that's good. Oh, well, that's because of this. All right, let's try it again. Run test once more. All right, so that does work. So 4, 30, 22, 21, etc. Okay, good. And then we can just do stuff. Let dbg I'm actually going to use print line. Okay, so we're going to do match. Is 0 match on num dot leading zeros. Sorry, I'm a bit slow today. All right, hold on. I think we might just be able to code it. Okay, but we need to look at the rotation operation. I think it's like rotate left, rotate right. This is annoying. Shift a bit to the left by specify amount n. Yeah, I think that's what we want to do, like a left shift. Left shift by 1. Is that right? Hold on. No, I want to do the other one. Rotate left, playground, please. 0B, 01, 0B. Let M, rotate left. Let M equals 0B1. Run. Oh, wait, does that work? You must specify a type for this binding. And I32? Oh. Let's go. Left 16, right 1. We need to just print it. Print line. What is it? Like that? Hex. No. Oh, hold on. We did a rotate left by 4. I want to rotate left by 1. Print line. Assert eq. There we go. Please work. Left 2. Right 1.
Hey, Josh, we're done with part 1.
Oh, I'm like super not done. I'm like
Cool.
still parsing like binary numbers and like tripping all over my feet and stuff.
No worries.
All right.
Do you want a hand, or are you doing all right?
I'm having fun. Let me put it that way. This might take a while, but I'm learning stuff and like remembering stuff, so I'm happy here.
Cool.
We're actually figured out in Rust, like how to do the shifting thing. I'm still like working on it, but we have like a method on every number type that's like count leading zeros.
Oh yeah.
So we, if you couple that with like a loop where you like do a left shift, you can just look at like, hey, do we have a leading 0 or not? And like loop through it like that, with like a rotation of the numbers for the length of the string, essentially.
Yeah, you could also so I implemented the initial part of counting everything just on strings and characters, but if you're doing it on the binary numbers instead, you could
Oh right.
just do an and with 1, and then right shift the number and with 1, right shift the number and with 1 over and over again. Keeping track of how many times you've right shifted, that will tell you which position in the vector you're writing to.
Right. Yeah, that makes sense. Okay. Yes. Yes. I am working on. I'll do this. I'll do this. We're gonna do this.
Cool.
We're gonna do it the fancy bit shifty way.
Nice. Good luck.
All right. Thanks. Ugh. All right, chat. Do we have this? I'm not sure. All right. Wait, is it because like that doesn't work, and then we know that that needs to be a thing? Hold on. That should be a thing, right? Oh, left hand. Is it? Instead of like rotate left. Is that the answer? Is that what we actually want to be doing? No. Ah. Left 10. M. 0B. So what is 10 in binary? So that is 10 in binary, I think. 2, 4, 8. Yep. Thanks, everyone. Oh, there we go. Yeah. No, yes. And, okay, I can do this. Okay, so and oh right, yeah, hold on, we're just gonna use that in our code. let's stop doing this. All right, so we have like our number here. It's gonna be mutable. Pause. Yeah. How do we know the length of a number again? There was a fancy trick to do that. I mean, we know the amount of characters in line, so let cars equals line.len. Yeah, exactly. For pause in cars, let's rename this to len. For pause in len. 0 we are going to do the fancy like left shift thing. Has okay, this is num, no implementation. Result parsing error. Okay, so unwrap function never used. Okay, let's give this a shot. We should be, so here pauses from the right. I just want to see if it does anything really. Okay, so we're getting like a bunch of bulls. So here pause is from the right. I feel like so my bit twiddling stuff is like super not there. Okay, I feel confident about the parsing. I feel confident about the line. Kind of copy paste this. We can get rid of those. So that was a warning. Okay, what we say here. Okay. Num and equals 1 pause. Let has equals oh no, wait, hold on. 1 position. Len minus pause minus 1 instead of pause, I think. Oh, I guess I'm kind of just reading chat comments now. Hold on, I actually need to properly think through this. This is super broken. I'm getting super stuck. I should have done the easy way and then the fancy way maybe, but I immediately jumped to the fancy way. I'm kind of like out of my comfort here because I don't do bit twiddling very often. Why don't I go with right shift? If num and ob1 sum plus equals 1, else sum minus 1, bit in that pause will be bool. Okay, I don't fully understand that comment, but I kind of understand it. No, I'm paying like a little bit too much attention to chat rather than like thinking it through, but that's because I am sleepy as well. I appreciate all the help, by the way, but I know I can do this. All right, let's delete that. From scratch, what we have is a number. We want to like left shift it, and then we want to mask the first number. Instead of masking it, I'll just do the count like numbers. So let's just do that part, right? Oh, that's what n is. What, or is that true? Yeah, there is a fun. Okay. Numerate. No. All right. So enumerate returns index comma line. Yeah. Sorry, I'm getting like slightly flustered. Okay, so we have the index because we're attempting to like construct a new number, right? And what's that number called? If we look at our problem again, this is gamma rate is binary number. Let gamma equals 0 u16. Let mut is it epsilon or something? Epsilon equals not gamma. Gamma dot not. Does that work? Is that a trait? All right, that works. And then our result is gamma times epsilon. Let's just make that zero. So that's just u size. All right, good. Okay. All right, what's chat saying? Right shift. Convert to pause to be from left, so maybe right shift and left shift is the same. All right. Okay, so we have our number in binary. I'm actually gonna do I wanna have a quick little debug routine. Is this it? Rust stood fmt binary b binary. How do we do that? Oh, colon b. All right, my bad. Is it like this? Or is it just like that? Type mismatch. I32 as I size. U16 U size from Steroradics. I32 is epsilon here, U size. Gamma is also U size. What's going on? Let's run cargo check. Expected I32 found U size. I don't understand what this is happening. Resolving That makes no sense. That not self output. Oh, there we go. Okay, so that was the issue. And if we run the test, we will be getting our numbers, I think. We're running one test. So first number, 100. Oh yeah, that's correct. So no leading zeros. 1, 2, 3, 4, 5. How do I do the length? There is a way to do that. Has 3 right aligned characters, has 3 fractional digits. Oh, is that the first one? If we do this, 5. Does that work? No. Oh, it's positional argument. Padding. A little bit of a slow one. Nah, it doesn't matter. All right, so that works. We can now look at our number. I still want to get the padding. All right, hold on. Colon 05 or something like that. Uh, 05B. Yeah, exactly. Cool. Okay, run test once more. It's been so long since I've done this. But okay, good. Okay, now we get our full like thing. And if we like shift it once, what do we get? Oh, crow test. Well, 0, 1. All right, but we don't want that. So we want to get dot rotate left 1, right? We don't want to shift it. We want to rotate it. So once more. One, 2, 3, 4, 5. We're doing like rotate right. I think we want to rotate right. And we want to count trailing. Is that right? So we want to have. Hold on. We can debug this properly. Num, common num, rotate right. So we can look at both variants. Oh no. Oh no. What's going on? Rotate right 1. So that's annoying. But okay, here we have one. Oh yeah, like right shift. Yeah, you were entirely right. Is this one? Yeah, exactly. That's better. That is way better. All right, what? No, we need to flip it. Hold on. Okay, run tests once more. There we go. Oh, okay, that is way better. Okay, and then we can do a thing where we do where we fill the number right to left, right? So for each iteration, or actually, num equals 1. Is this right? Well, we need to do trailing or something. It's snowing in Copenhagen. Yeah, it is. Oh, door just opened. A cat just entered. Just going for a nap behind the couchy. Two cats have entered. The second one is like sitting right here. It's really cute. All right. Yeah, exactly. So this is what we want. Learning for myself here is step one. Whenever you do like any kind of bit shifting, immediately jump to like creating a debugger. So you can verify the output, because I should have been doing that. All right, but we have the shift at the end here. If pause not equals 0, this is so janky. All right. Is this it? I don't know. Whatever. Let's just run this and see what pops out. And so we have something running. Yeah, we're like, keep shifting. That becomes that. We like keep doing like rightward rotations. That's good. All right. So we have the index, and we don't want to like rotate a full number at once, I think. We want to do a instance count, right? So we want to like offset by index, I believe. So this is wrong. Oh. Cats like keep opening the door and closing the door. It's really cute. So here, there, and then we want to offset by pause, like there. Am I right? Wait, is that wrong? That's wrong. Can't find position. Index. Okay. So index 0, that should just be the current number. Hey, Rihanna. That's super cute. Yeah. Panicked at assertion failed, left and right. Okay. 0, 100. Wait, do we just loop through this exactly once? Yeah, I guess we do. Okay, so we do like need to loop over every single number completely. And I guess we can like, did we do what we were like doing earlier, what we like to account? I think we almost have to. Yeah, maybe mutating them is not ideal. I don't mind mutating number, but like we can mutate it. We just like need to track the indices like differently. One sec. Sorry, there's vacuuming going on in the other room. How's the sound? Is it okay? Do I need to like up like noise cancellation or something? I don't know. Oh, okay, glad. Rena says, I just looked at that task and my brain broke. Yeah. 0 U size. So we parse the number once, right? That's what we said. All right. Sound is fine. Okay, I'm glad. I don't mind like spending a little bit of time in this. I think I think this is like super fun because I'm doing something that's like slightly outside my comfort zone, but I have done before, and it's like the problem is like slightly annoying as well. All right, so once more from the top. We have our number. Sorry, I'm distracted by the vacuuming now. Okay, so we keep shifting through stuff there. Let mut orig equals num. And then we can say, just for debugging purposes, run it again. All right, now we get like the full thing. There we go, and that's like the full shift. The question is, how do we track this? Right. Because we can do the count, but we need to like track occurrences. So it feels like at the end of the line, we will need to like count the occurrences, and we will like need to know more than it's annoying because it's slightly the like it's like a weird shift going on. Also, we've been talking for 45 minutes about this. It's great though. Do y'all like see the problem what I'm like talking about? So we can parse like the full number in like one go. If we like don't want to collect the numbers first, right, and then like loop over each number individually, maybe we should be doing that. Maybe that is the better approach. But if we want to like do it just in time, that's like slightly annoying because we don't have like access to numbers at first. I think we should do that. Okay, let's collect the numbers first. And then we can lines dot map line. Okay, we're gonna simplify it for us, otherwise we'll like never finish. Line.len. Oh yeah, we don't need len. We don't need that. We don't need that. We don't need that. Collect. Vec. Boomerang says, I don't understand how you can do it just in time. You need global information before you can start producing the first bit of output. Yeah, you're entirely correct. However, I was wondering if we could like do it without allocations, essentially, where we like instantiate a counter. Like you do need like, well, do you need global information? You need to have gone over all numbers at least once before you have like your final output. And I was wondering if we could somehow cheat. I think size solution did need allocations. Oh, I haven't like looked at size solution. I thought they were like collecting first, essentially. So I'll be like super keen to like compare answers once we have something working. So that's what I'm shooting for now. Usize 5 for the counters. Yeah. Do we like know that for a fact? I haven't like even like looked at the output input. No, see, you can't like usize 5 it, right? We need these numbers are variable size. Like the input here and the input here is different size. So you'll need to like do a vec. So that's one allocation, but you know, that's also like fine. I'm just making it a little bit simpler for myself. So we have all the numbers at least once. That is good. We have a vector of numbers. Oh no, hold on. No, we do need to lend there. line.len. Is this right? Index len. There we go. All right, hold on. No, I do want to do this. Sorry. Let my counters equals vec. So for each line, we're going to push a number in. Yeah. Let my counter equals 0. Is that right? Line.len. If idx equals 0, then we're going to initialize like the counters. Let len, line.len. For in len counters that push 0. All right. I know this is terrible, but hold on. We're gonna make a terrible solution, and then we're just gonna live with it, I guess. Yeah. Sai is way better at this kind of stuff than I am, for sure. But I never claimed I'd be great at solving puzzles. Just promised I'd like try very, very hard. Okay. Okay, once more. So we have our number here. We have our like vec of counters. That's okay. Then we have like our gamma there. That is also okay. And I want to like mutate like our gamma more or less like in place. But we can do it at the final step here, right? I think we can. Where we shift into gamma. Pause. Hold on. We can figure it out. Oh, you've also solved it this morning. Nice. All right. Okay, so we have like the full shift here. And then we know that for a number, we can do count trailing zeros. So which one was gamma rate? The most common bit, diagnostic report is 0. Second bit of gamma rate is 0. Considering the first bit, 1, 1, and 0. 3, gamma rate, 1, 1, 0. So gamma has ones. U size. Okay. So our counters. Is that right? Yeah, we're gonna fill it from right to left. Oh, this is so annoying. But it's good exercise. If nom.trailing ones not equals 0, counters, is that pause? Plus equals 1. And then here at the end is line.len index. Oh, damn. Like, we don't know how many like lines we have, right? Oh, annoying. Yeah, no, I'm really messing this up. I feel like I almost like should start from scratch, but that'll just take like forever again. Let's change this. Okay, we're just gonna like allocate all over the place. It doesn't matter, because I'm way too lost. All right. So for index line, inlines that enumerate. No. Slet lines. Dot map. We're back here. Oh. no, no, no. Let numbers equals that. Okay, so we have our vec of numbers. No, we don't. Okay, so we have our vec of numbers. Good. Now we're going to iterate over each number. Let line count equals numbers dot count. Yeah. Okay, so now we have our len. Sorry. Yes. So now we have our length. Okay, next step. We are going to iterate over each number. We're just gonna like loop a lot over the vec of numbers, I think. For how many times do we do this? Do we know the line len? What's a binary thing? So we want to like create a number that's exactly as long as this other number, right? So we have 5, then we need to like, no, it's like 5. No, I don't want to do that. So we know the number of numbers that we have. I was like done so quickly with this compared to mine. Hold on, I need some water as well. And there's a cat like passed out at the bottom of the couch. I showed some hubris. I thought I could like do this with bit shifting like all in one go. I didn't realize we like need to like do multiple passes. Or like as Boomerang correctly pointed out, we need like global state. Hubris. How's everyone's morning? Maybe you can walk through it with Sai if you get stuck. Yes. Sai.
Hello.
Hey, so we're still on the first problem, and people in chat have been like, "Hey, hold on, you got somewhere there who's like already solved it. Do you want to like help me out for a bit?"
Yeah, sure.
All right, cool. What's the best way to do this? Screen share?
Yeah. If you screen share, I can rejig my stream and I can show your
All right.
screen on my stream. I think I can give it a shot.
All right. I think if I do this. Okay. Okay, but your face is now like completely frozen on my screen.
Oh, whoops! This has gone to the wrong thing. Screen share.
Okay. Because like I am so stuck. I've like, do you know the thing when you like immediately jump to like the difficult solution and then you get ultra stuck? That's where I'm currently at.
All right, folks on my stream should now be able to see your screen.
All right. So I've got a giant mess of code. Like I can tell you like what I do know. Some things I have figured out. I figured out that we can calculate the epsilon by doing gamma.not. So like doing a binary inversion, and then the result is gamma times epsilon. So that's one fact. We've got the number parsing working correctly. So I was like, oh, let me like do this in like a single loop in a single pass, not realizing that we like needed all the facts before we could like do anything. So we are correctly parsing the numbers, and we have that. We know how many lines we have, so we know what the count is. We can probably like even calculate the offset, but the main loop is where we're like ultra stuck.
Okay. So you're getting lines, you're translating everything to binary.
Yes.
Which is doing it the hard way, but then you are, okay, you're saying for index and line to enumerate the length of the line.
Yeah, so this main loop is like ultra broken, and we need to like essentially retool that to something more sensible. And I was hoping we could probably kind of copy your approach, like your base like logic.
I mean, I did mine in a different way. You're doing yours based on converting your those strings to integers and then trying to work from there. I didn't bother converting the strings to integers. I just worked directly on the strings.
Yeah, I see. I mean, we don't need to do that either. Like we had it slightly the other way around. Like we know that if we have an integer, we can like look at the rightmost bit essentially and like shift and like look at the thing.
Yeah. So basically what I would do is, okay, you don't want num.trailing ones, I think. You just want to and the number with 1. Okay. So what I do is, so you've got the index, right? I would get rid of that whole loop. The whole inside of that loop.
Yes. That hurt, but that's okay. That's why I called him for help.
Yeah. Sure, the whole of that loop. And then, so you've got the index that you're, I don't think you need to enumerate those lines.
Okay, well, let's get rid of that. All right.
Okay, so you've got for each line in lines.
Yes.
Okay, so you're gonna want something to some data structure to count into. So like a vector.
And then we want it to be the length of like a single number, right?
Yeah. So if you get the length of the number of positions you'll need will be the length of the number, which is, well, if you've already converted it to an integer, then you would need to take the log 2 of
yes
all of the numbers and find the max.
Wait, are you saying the max? So we like need to loop over it and get the max length?
So I mean, what you need to do is find know how many positions were in your input, right? The easiest way to do that is just count the length of the string which you got at the start.
All right, so I'm gonna do something terrible, which is I'm gonna write that here. We're gonna count it exactly once. If len dot is none, len equals some line dot len.
That'll do it.
Does that work? Yes. And then here,
okay.
Len.
Yeah, exactly. Okay. And then in your loop, you're gonna want to. So you're looping over each line. So then you want to loop, but for. Well, you only need to go until the number is 0. So basically, what you're gonna do is you're gonna have a counter.
Mm-hmm.
Inside this loop.
Oh yeah.
Which starts at 0.
Yes.
And then while the line is not 0.
Okay. Oh, smart.
While the line's not 0, you're going to AND it with 1.
Oh, I think numbers. Is that right?
Yeah.
Yeah.
You're going to check if the result of ANDing the number with 1 is 1. So
yeah.
In Rust, can you just say if num and 1?
Num and 1. No, I think that returns like a number, right?
Okay, then if num and 1 equals 1, then
Yeah.
no, if it does equal 1.
Oh.
Yeah. If num and 1 equals 1, then you're going to not increase the counter. You're going to increase the element in your counter's vector at the current position.
Right.
So your counter should really be called like index or something.
Okay. I appreciate the
not
help,
that one. That one was fine as counter. The one in there should be like IDX or something.
But then probably
no, because that's not what you're counting. This is an internal thing. Yeah,
right.
Exactly.
Like that?
No, here you're increasing your counters. So you're doing counters indexed by index plus equal 1.
Oh.
Because you're counting the number of ones at which are in this current position, and then outside of this if statement, you're going to increment the index and then right shift number by 1.
I see. Is that it?
You need to do. Can you do?
Yes.
Right. Yeah. Exactly.
Oh. Yes. Okay.
Yes. Okay. So that should give you your count.
I see. And then at the end, we like need to like do a loop over every counter and like construct a number, right?
Yes. Exactly.
Yes. Wait. How are we like pushing into here? Oh, I see what you did with the index. Oh, hold on. We like need to loop from it like left to right, right to left.
Depends on how you're going to construct your number. So the way I did it was I did a left fold. I started off with 0, and
smart.
On each accumulation, I left shifted the accumulator by 1 and then bitwise ORed it with the new number.
Oh, that's smart. Counters that.
I mean, first you need to convert your counters into either 1 or 0, because currently it's
oh, true.
You've got your count, so you need to do like a counters.map and change it to 1 or 0 depending on whether it's greater than the half the size of the lines.
Yes. This one's like so much trickier than the last 2 days. Line count, divide by 2. Does that work? No. Well, do you know those days when you're like, do I know this language at all? Do I know how to computer?
that was me yesterday.
Oh, actually. Okay, let's do a little iffy here. Wait, no, that's not how you write an if statement. Oh my God. True, else, false. All right. Do we have a thing? Oh, We don't have a semi at the end. That's probably the issue. Yeah. Yes. Okay. And then we do a fold. How does fold work again? Fold takes a starting number accumulator X. So 0.
Yeah. 0, and then a lambda, which takes accumulator, and X. Yeah. And that's going to return. So you're going to left shift the accumulator by 1, and then bitwise OR it with X.
1.
You can just do this all in one line.
Oh, you mean? Hold on. Does that work?
I mean, it's up to you. You can, yeah. Bitwise OR, not bitwise AND.
That's this one, yeah.
Yeah, and get rid of the equal sign.
Oh, I see. Oh, that's super fancy. Oh,
So
but
that
we don't use the X, do we?
sorry, no, bitwise OR it with X.
Yes.
Okay, so that will give you the gamma to get the epsilon.
Yeah. Someone in chat was. Go ahead.
Yeah, to get the epsilon, you would want to do the same into iter and map, but then your fold, the only difference is instead of bitwise ORing with X, you bitwise OR with X word with 1 to switch it. Or I guess you could flip those. Yeah. That works.
So this is let gamma equals let epsilon equals. Oh my god. Counters. Oh, let's just do that. That should work. Line count counts. Okay, that works. Run tests. Did that work? No, we're getting errors.
Hate errors.
Oh my god.
The worst.
Yes, absolutely. Okay, so we're having a bit shift error somewhere. I'm starting to like better understand like why you opted not to do any bit shifting. To debug bit shifts. All right, I think I can like attempt to debug this. How's the second one, by the way?
I haven't started. I was implementing a general left and right fold in C++.
Of course you were. Yes. All right.
All right, I'll let you get on with that. Good luck.
Thank you. I'll stop the screen share. Thank you. All right, everyone. We have stuff going on. Thanks for the suggestion, Ariana. That was indeed the right suggestion. Just asking Sai for help. Way better. Yeah, so this is not ideal, but yeah, it's not the worst either. All right, let's take a look. What do we got? So we're getting 234, what we need like right 198. So our help text gives us some help. Gamma rate is binary number, should be 22. Epsilon rate 9. Gamma, epsilon 13, 18. That is extremely off. I wonder if we like need to reverse it or something. Oh wait. Counters.rev. Verse. Rev. I wonder, yeah. Just intuition, because the numbers are so far off. Just wonder if we messed them up. Hey, yeah, that was it. All right. Okay, yeah, so that was it. We were like accumulating exactly wrong way around. Hey, we just figured out the bug. Ready for part 2, I think.
Nice, good job.
Yeah. So the bug was we were iterating the wrong way around. So we need to reverse the iterator, and then the accumulation like worked out the way we wanted it to.
Cool.
Yes.
Okay, let's have a look at part 2 then.
Oh, hold on. I forgot to like input the proper input. Our test pass.
Oh, yeah, you need to actually get it.
Yeah. Hold on. This will like take 2 secs. And if not, I'll just copy and paste your input or your answer or something, and I'll figure it out later. Paste. Make sure we call it the right way. Hold on. Include 3.txt, and then we say print line day 3 part 1. Sorry for interrupting there. Parse 1 input run. Okay, day 3 part 1, inputting that into the puzzle, submit. Yay. Okay, we have the text for part 2.
Nice. All right, give me 1 sec. Let's see if I can get my fold to compile. It's almost there. It's not quite. Input range. Yeah, I've implemented like there's a standards paper for generalized left fold and right fold. So I've just been implementing that. It's almost there. It's so much random concepts and requirements.
I'm seeing now that Rust has fold and rfold. So left fold by default, right fold otherwise.
Yeah, that makes sense.
Is it right then? So like reversing, I could unlike a right fold potentially?
Yeah.
Oh, cool.
All right, I'll do this later, since this is not quite there yet.
Ooh, amazing. Yeah, that worked.
Oh. All right, let's look at part 2 then.
Yes.
Okay, next you should verify the life support rating, which can be determined by multiplying the oxygen generator rating by the CO2 scrubber rating. Both the oxygen generator rating and the CO2 scrubber rating are values that can be found in your diagnostic report. Finding them is the tricky part. Both values are located using a similar process that involves filtering out values until only one remains. For searching for either rating value, start with the full list of binary numbers and consider the first bit. Then keep only numbers selected by the bit criteria for the type of rating value for which you're searching. Discard numbers which do not match the bit criteria. If you only have one number left, stop. This is the rating value for which you're searching. Otherwise, repeat the process considering the next bit to the right. Okay. So we have some criteria. We start off in the first bit, we filter by that criteria. We move on to the next bit, we filter by that criteria.
Okay.
The bit criteria depends on which type of rating you want to find. To find oxygen generator rating, determine the most common value in the current position and keep only numbers with that bit in the position. If they're equally common, keep values level 1. Okay. Find the CO2 scrubber reading, determine the least common value. Okay, this makes sense. We're basically just doing the same thing as part 1, but we're adding a filter to it and doing it over and over again.
Right. Because we're like doing like a full reduction. So instead of like accumulating stuff, we're like, we need to get the accumulation and then like start filtering until we like have one number left in our list. Right?
Yes. Yeah.
Oh, that's annoying. Do you have any like idea for sort of the general like data flow of how to implement that?
I think it's going to look broadly similar. I think you're going to do the same thing with getting the counts, and then oh no, because you need to do the counts. You need to do the count every time you filter the numbers. So you can't just do the counts once. You have to, every time you so you consider the first position,
right,
and you count those, and then you filter, and then you move on to the next position. You have to count those. You can't do it in one batch at the start, I believe.
Is that right? That's super
annoying. Yeah, so it's keep only numbers selected by the criteria.
No, I think we can do the count like once, which gives us a new bitmap, and then we can run that resulting bitmap essentially left to right over all the numbers. Like
no, because when you every time you prune, you remove some sets of numbers, so the most common bit might change.
Wait, is that true? I think you're right, but like where does it say that?
So the algorithm is you keep only numbers selected by the bit criteria. If you have only one number left, you stop. Otherwise, you repeat the process. But when you discard numbers, you change the count, so you have to recompute it every time.
I see. Oh yeah, I have someone in chat like double confirming that what you're saying is exactly right, and they made the same mistake I did. So yeah, okay. Oh, okay. So we filter, we recompute it, and then we filter and we recompute it, and that's how we like shift through it.
Yeah.
Okay. Cool. All right. Yeah. What you're saying about like it's roughly the same as last time makes sense. It's just more steps involved.
Yeah.
Okay. Good luck.
Yeah. You too.
Thanks. All right, chat. We're in trouble. UberX says the redshift check might change too, I think. Yeah, that makes sense. Okay. Well, first let's fix this where we have our little printy, do the nice printy thing. Output 1. All right, then we like run this, make sure that that's like printing nicely. Day 3 output 1. Okay, there we go. Day 3 output 2 is parse 2. And we can do this there, and then we do this there. To do, you did float division. No. No way. Oh my God. Oh, okay, so there's a lot more text here. All right, so we need to verify this, and we'll likely want to like verify the intermediate steps as well. $230. All right. All right, so we have our tests in place, but we might want to do a bit more. Okay, so we're doing essentially what we did before, but we need to like do intermediate filter at every step of the way. To find the oxygen, generate a rating, determine the most common value, 0 in the current bit position, and keep only numbers with that bit in that position. So yeah, we like need to like recompute. It's like we are filtering through the numbers as well. So it's good that we have the number parsing step first. Let counters. Yeah, so once we have this, and so like counters there. Oh my God. It is like super messing with my brain. Start with, okay, so let's read this through. For example, to determine oxygen generator rating value using the same example diagnostics report from above, start with all 12 numbers and consider only the first bit of each number. There are more 1-bit 7s than 0-bit 5s, so keep only the 7 numbers with the 1 in first position. Oh, that's so annoying. Then consider the second bit of the 7 remaining numbers. There are more 0 bits 4 than 1 bits 3, so only keep the numbers with the 0 in the second position. 3 of the 4 numbers have a 1, so keep those 3. 5th, 6th. Okay. I'm thinking of like not doing this in binary. We're just going to allocate all over the place. We know we can do it if we want to, but let's not make the same mistake again. I think. Is that what we want to do? Yeah, strings are nice for random character access. Exactly. All right. So start. And we're going to change this. We're going to skip that. I did a vec version first and refactor it to bit twiddling nicely. Exactly. That is the better approach, in my opinion. And then here we say for car inline.cars. Actually, we're just going to do this. Line.cars.map car. And then we say U8 from stir car unwrap collect. And here we say we get a vec of U8, right? Is that correct? I think we can say car.parse.unwrap. Expected U size found 0. To do no method name parse found 4. Type car Aster. Oh, I think we can just do like as you wait. Isn't that right? Yeah, it's a primitive. All right, cool. So we have our vec of like numbers. I do use in Java because I like pain. Is it really that difficult? I didn't know that. I felt like Java had like decent bit manipulation stuff. Like the only like other language that I'm like comfortable in would be JavaScript. Haven't written it like in years though, but I used to do like only JavaScript, and like doing this in JavaScript would be not easy per se. Okay, so we have our vec of x of U8s. That's good. And all right, so what's the formula? Yeah, Java has lambdas too. That's what I thought. Oh, interesting. Wait, a U6? Does Zig have random like integer numbers, or is that like a typo for instead of like U8? Or is it like a bit shifted? I should like stop reading chat. Oh, it has like variable size numbers. Oh, cool. It uses LVM, right? Because like LVM has like arbitrary like size integers, I thought. Ooh, whoa. Yeah, cool. Cool. I like that LVM has like lowered the bar for like languages that are like actually good to like be written. Oh, you keep quiet. Keep chatting. It's just I'm not super awake. This is the kind of like problem that I'm just not good at. Like bit shifting is like not my thing. Like have me like write parsers all day long. Just bit shifting. No, thank you. Oh yeah, I'll look at that once we're like done. I think we should have time for that. I don't have like big plans for today anyway. It's Friday. Tend to be a bit more easy for me. Okay, we need mute numbers. So what we'll be doing is we will be loop while numbers dot len not equals 1. Right. Oh, we need to like clone this, won't we? Yeah, we can clone it later. Cool. All right. So we need to, all 12 numbers are considered the only first bit of each number. There are 1 bit, 7, then 0 bits. So keep only the 7 numbers with a 1 in the first position. Numbers equals, is there a better way to do this? Not pop. I'm not looking for vec pop. I'm looking for vec remove. Removes and returns the element at position index within the vector, shifting all elements after it to the left. Yeah, it seems better. While numbers len, good old Java. Hey. For number in numbers. Yeah, and then we get someone's asking something about Twitch token stuff. Yeah, so I unsubscribed from the Twitch affiliate program yesterday because I just want to like push to YouTube sooner. So I don't know if this is like the sub token system or just me having like stopped being like an affiliate. I didn't get confirmation that like went through. But if you're like a Twitch affiliate, you can't like upload. There's like exclusivity with YouTube, and I didn't want to do that. I just wanted to like be able to upload on the day of. Yeah. So maybe that's why you can't like sub to me or something like that. I'm sorry. Like also, like, yeah. Oh, you tried on other streams and it won't work. Oh, yeah. I don't know. I'm sorry. Okay. So, number 0. The pop front. Dot lines dot map. Lines dot cars dot map dot rev dot map. Number dot pop. Is this into iter? This is annoying. Hold on. Okay, let's try it again. Let's take a look. Okay, we're just gonna like clone all over the place. I am not gonna mutate in place. We're just gonna make the super turbo inefficient version, and then we can smart it up later or something. Yes. Okay, let's just do like one loop. for number in numbers. And then we take a look at the equals number. Let's not reverse this. So let's take a look at the first bit. Is this pop front? Yeah, we want a pop front. Back DQ. Okay, so apparently that's in scope. That's nice. Dot pop front. Yes, give me that bit. Let number. Okay, then we have the bit. If there are more 1 bits than 0 bits, keep only 7 with 1 at first position. For number and numbers. Lat positions equals vec numbers dot length. Enumerate positions. Is this right? Level count equals 0 if bit equals 1. Actually, count plus equals bit. Is that right? Yeah. Positions, IDX. So that's our count. And then we need to track our positions one more time, I believe. Numbers dot iter dot enumerate. Oh, what? Oh, pop front dot unwrap. Variable does not need to be mutable. Count plus equals bit. Oh, it's because we're not reading it. Okay, what do we got? So we have our positions. What does positions mean? That's not a good variable name. Okay, so we have our numbers. We convert that into an iterator. We enumerate that. Then we say, oh, there's 2 cats here. Hold on. There's a naughty cat sleeping on the couch again. It's very cute. I was like, oh, where are the cats? But the cats are just here. Sorry, stray thought. Okay, so we have our numbers. Then we have our vec. We enumerate that. We pop front, so we get the first bit. We increment the count by bit. So our count is show cat. Yes, indeed. I think you better filter a vector until you get the last one with current approach and see how you get to the answer. I'll just clone everything. Don't worry about it. Yeah. No. This is all fine. I will filter, but I'll filter by hand. I will remove anything from the thing that isn't like a thing. Sorry, that was vague, but it's okay. We're gonna write a big loop around this essentially. Oh no, you are entirely right. Super annoying. Yeah, no, I will filter because if you pop from a thing, the index changes, that's terrible. Yeah. No, you are correct that filter is easier. We'll filter in a sec. Don't worry. We'll like recollect again. So now that we know all the numbers, oh yeah, I think we can like do a zip and then like do a filter on the zip and like collect into that. Yeah, maybe that's the better one. Okay. I think we can just do clones. All right, so we have our pop front, then we have our count plus equals bit, and that's a total amount of count. Okay, what was the filtering? Then consider the second bit of the 7 remaining numbers. There are more 0 bits than 1 bit, so keep only 4 numbers with a 0 bit in the first position. So that's our positions, so that we know like for each number we have that. Count ones. Count ones plus equals bit. Actually, if bit equals 1, count ones plus equals 1. That's a bit clearer. It's a bit annoying, but it works. Does that work? That's better. And position index equals bit. All right. And then for our next step is we will want to filter the number and the positions. Hold on, a cat wants out. I also need to run to a restroom at some point. But I want to do the zippy loop real quick. All right. So we have positions.clone. .zip. We can just do numbers.clone the intuiter. .zip numbers.clone. Actually, numbers.clone positions .zip exists for struct vec, but the straight bounds were like not done. Wait, what's the issue? Into iter? Is that it? No. Oh, we need to do that into iter there, right? Is that it? Yeah, I think that's it. Dot filter, filter map, sorry. Num pause. And then,
Hey, Josh, we're done.
oh my God, you like gave me a heart attack. All right, cool. We're still working on it. Do you want to like screen in?
Yeah, sounds good.
Cool. I'll screen share once more. How do I screen share? Wait, okay. We have the screen sharing app right here. Ta-da. There we go. Your face is once again frozen on stream, but we'll fix that tomorrow. So for the words, this timer, I need water. All right. So this time around, I decided not to like jump straight to bit shifting and like, you know, trip and fall straight onto my face. Instead, we did the, I guess your approach, at least initially, which is to parse into a double-ended vec of like U8s, right? So each character becomes each like bit is represented in like a vector, which is much easier than like doing bit twiddling. So here we're like still struggling with our little loop. What we got here is so here we collect all the thing into like a vec of vectors essentially to represent our numbers, and then we have like our first. I was like writing a first loop here, where we how to explain this? What are words even?
So why do you have a vec of vecs?
We're parsing each number, each like binary number, instead of like parsing it into. Like,
okay, right.
Yeah.
No, this is because C++ is just like characters or bytes. So yeah, okay, right. I understand. Yeah.
I mean, we can do that. We're doing car as U8 right there, but the conversion isn't like implicit. We like, so yeah. Okay, so what were we doing? I was just writing like the filter loop here, where we're doing a filter map. So we have like, we've been tracking like each position of the number. And then we have the count here, and then the numbers.len, I believe. They're, oh my God, should keep equals something like count ones bigger than, bigger or equal than, what is it? Numbers.len. If should keep some else none, something like that. I think that's like our first little filter loop that we have here. Does that make sense?
You don't need to keep positions.
What do you mean?
Vector. Like you're only checking each position one at a time and doing the filter based on that. So you don't need a positions vector.
You don't need a position vector. We do need to like, in order to like filter, we like need to track which number each number was, right?
You only need to track the number of ones in the current position you're looking at. You look at the positions one at a time.
Oh yeah, positions is the wrong name. So we're like doing like double looping, I guess, because we need to count them. Words are difficult. Concepts are difficult. My brain is like soup. So positions is essentially like if we have like a list of the numbers, like a list of each like number, then positions tracks not the positions, but whether that number was a 1 or a 0. So that once we've like counted all of them, we can like take the two lists and based on that like filter. This is like not quite correct.
Okay. I basically did it. I counted all of the ones in the position. I worked out what was the most common, either a 1 or a 0, and then I just went through the list and erased everything that didn't have the most common number in that position.
Yeah, that's what I'm trying to do.
Yeah, I didn't keep an aside vector of all the positions. I just checked them again.
Oh, you just
because like it's gonna be the same essentially. Like
Oh yeah, you're entirely right. Yes. Yes, that is better. Yeah, way better, way better. Okay, that means we can like drop the zip. We don't need to do that. We don't need to do that. And we can just do a filter. Instead of filter map. Is this like should keep correct? I think it is, right?
No. It's the way I have it is thanks to Seth, because I had it off by 1, is whether the count is greater than the number of lines there currently are minus the count.
Number of lines there currently are minus the count. Oh, wait, what?
So the you're going to be filtering the numbers, right, each time.
Yes.
So current ones is greater than or equal to the size, numbers dot len minus the count.
Oh, yeah, I guess I'm like mutating the numbers vec, or I intend to mutate the numbers vec on each loop.
Mm-hmm.
So that would shrink anyway.
Yeah.
That means we could drop that, right? Because like count ones, numbers len minus the count.
It's basically like doing if count is greater than or equal to the length of the numbers divided by 2, but it does the integer division would mean that you fall on the wrong side.
Oh,
if
yeah.
It's even. So instead of doing divided by 2, you do numbers dot len minus count.
Okay.
Hey Tara, I should see you.
No comma, like that. Minus count.
Greater than or equal to.
Yes. Okay. It like my brain is like, this doesn't make any sense, but I trust you. So the words you said made sense, but then the outcome, like I'm like, huh? It's all good. Okay. All right. So then we take num index or yes, numbers dot pop front, num dot pop front, and then we have our count ones, and we can say something to the effect of if count if should keep what's the comparison here?
Why are you doing a pop front?
Oh, because we're looking at the numbers and we're looking at the first number in the array again.
Okay. You're. All right. I just kept track of the position in a counter, but you're okay. Yeah, equivalent. Okay.
Oh, yeah. No, you are right. That might just be better. Because that means we don't need to modify it. For n in 0 dot dot counter here number counter, and then here num. This is like definitely a thing. Like this type of problem is like something I'm terrible at. It's like if we're like writing compilery things, state machiney things, like yeah, I can like do it all day, but this kind of stuff, no. All right, so we have our filter function. We know our number, and then we say if should keep num equals 1 else num 0. I believe that's it. Yes. And then we have numbers again. Oh, we don't need to collect anymore. Is that true? Oh, we do. We do. But we can just mutate it. Numbers equals numbers there. All right, and this should give us like the first variable, I think.
Yeah. And then the second is exactly the same thing, but your if should keep is just flipped, I think.
Oh, we don't have the break condition quite yet. Numbers dot len equals 1 break. And then number. Does this work? How do you go back from a vec of bits into a thing? You wouldn't know the answer to that in Rust.
When you did the same thing you did in part 1?
Well, I did bit shifting
fold.
there. Oh, right fold.
Yeah, that right fold.
Oh, yeah, you are right. Yes, good point. Number 0, 0. Right fold, and then this is a conditional one, right? Where we like know the x, and x is like a bit, and that's just a number. Does that work? Oh, into iter, that numbers kind of move out of Thanks so much for like looking along. I know this is not the most interesting.
No problem. I need to head off in a bit because I got my talk later. I need to prep for it.
Yeah, that makes sense. Yeah, I'm going to time box this. I'm going to give myself another like 10 minutes to figure this out. And then I'm just going to call it quits and give up. Yeah. We got 1 star. One star is good enough for a problem that we're like not good at. Yeah. I love how I'm like stuck at like, how do I access a value inside of a vec? All right, I think I might be able to figure this out. I'm gonna just time box it.
I think I'm gonna head off, do some prep for my talk.
That makes sense. Yeah, good luck with your talk later.
Thanks.
It won't be like streamed live, will it?
No, it won't be.
Unfortunately.
All right, thanks everyone for joining.
Thanks everyone. All right. I will continue with this, even though Sai's popping out. I'm gonna give it another like 10 minutes and then just straight up call quits. Yes. Oh, let's hide Sai there. Thanks everyone for like sticking around. We've been going at this for like 2 hours. Do we have a zip somewhere? No, we don't. Move occurred because value has vectq wait, which does not implement copy trait. see. Is that it? Found for type integer. So we have our accumulator, and then we have like x, and x is that, and then we say x dot pop front, right? No. Oh, this is so annoying. I'm gonna run to your restroom, actually. I'll be right back. I'm going to give it like 10 more minutes after that. You can all enjoy the cat, I guess. Small cat. Wait, hold on. I can like full screen this. Where's the thing? Camera there. Yay, cat. Be right back. Hey, Chad. What's up? Doing breakfast? All right. All right. I am back and I feel refreshed. And we've been sitting for 2 hours. Let's take a look. Okay. Okay. All right, so we have our right fold, our X, and we return that. Our X would be a U8. Yeah, so we don't need to like pop front. Can't move out of index of vec because value has, which does not implement the copy trait. Is that it? Yeah, that was it. I forgot a clone call. It was that easy. All right, run tests. Hey, okay, well, day 3 test first worked. Second test is hanging, so that's not good. Probably because we have a infinite loop here. Numbers len equals that. I think we can like, so if we run this once more, we can like take a look. Oh, wait, we just didn't compile. Oh, that should do a trick. Okay, once more, once again. Okay, we have like empty numbers. So let's just do does that work? Yeah, I think that works. At least we'll like stop at some point, but we'll get like the wrong answer, and that's okay. Num should keep I forgot a comma there. Yeah, right. And then we can remove this debug right there because we don't need that. And then we can like test this once more. False, 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 false. Okay, so that's not working. Oh yeah, like debug is like super nice because it can like be used inline. And with Rust Analyzer, you type .dbg tab, and then like it'll like wrap the current expression, which is nice. I like it. And then you can like auto remove it like that as well. Discarding it due to a condition on line 71. Yeah, I totally am. Oh, no, I'm not. Sorry. Like this is our switch, which says like, should we keep the ones or should we keep the zeros? I should rename this to keep ones. Right. And then we say like, hey there. Keep ones. Oh, and we're like printing like full on numbers there. Num. So our num counter is like, oh, okay. What is our num counter? Oh, but that's like the full number. What we want is we want to have num counter and then I've been reading too much C. Yeah, that's a vibe. Oh, okay, so that's our vectq, and then we look at the counter. Yeah, so that is a vectq. 48, 49. But that's just like straight wrong. It should be like zeros and ones, right? Car as you wait. Let's just do like, let's go there. Let's try that. Let's see what we're like even collecting, because that feels wrong. Yeah, 48, 48, 49, 49. I think that's because we have like car as you wait. Yeah, we could do that, but that is terrible. That's the ASCII value. Yeah. We can just do, so what do we know we have? Do we want that to be characters? As you wait. True. Is sorry, car equals B1 byte 1. Okay, let's take a look if that works. Mismatch type. Expected car. Find that. Expected car. That's better. All right, let's take a look again. Run tests. What's our input? Okay, 0, 1, 1, 1, 0, 0, 0, 1. Okay, good. That is way better. number, okay. 29. All right, let's take a look at our output. Oxygen generator rating is 10111. What is this, like a regular fold instead? Is that what we need to do? $23 in decimal. Hey, that worked. Okay, cool. Hey, we got it. All right, so our first thing's correct. And this is our oxygen rating. Oh. All right, sweet. That's good. What if we like rename this to numbers equals numbers dot clone, and then we rename this to oxygen nums, yeah. No, we're not gonna do that. Are we? We're not gonna do that. We're just gonna copy this whole loop. That's okay. Okay, there. And then we rename this to, what's the other one? CO2 scrubber nums. CO2 nums. Should keep num equals count zeros. If bit equals 0, we count our nums. Like that. Okay, maybe that works. CO2, CO2 nums, CO2 rating. Oh. We need that to do there. Okay, let's run it once more. CO2 rating 15 or 10 in decimal. Okay, seems like, yeah, exactly. Should keep check. Okay, once more. Run test. CO2 rating 22. Wait, that's wrong. Hold on, that was the previous output, but or like almost. We need to do a little bit of better look at this. Oxygen rating, is our oxygen rating still correct? Oxygen rating 23, yeah, yes, good. Let's debug that. And let's remove all of these debugs because they're not super helpful. All right, we're gonna run one more. Oh no. Where is that issue? Oh, there it is. All right. Right again. C02. Oh. Yes, you are entirely correct. CO2. CO2. Fine. What do you mean those are not the same thing? All right, so we need to get 01010 10110. Okay, so we're like super off, right? It's not like a clean little inversion, but it's like proper, not good. All right, let's take a look. All 12 numbers, and consider only a first bit of. There are 0 bits, 5, then 1 bits. So I think this might be wrong. Is that the thing? Hold on, maybe. 23. No, okay. We're just guessing, I guess. What did I just change? All right, so from the start, once again. Okay, count zeros. 0 num counter, if bit equals zeros, count zeros plus equals 1. Okay, so we have our zeros there. And the rule is determine the least common value in the current bit position and keep only numbers with that bit in that position. Okay, there we have it. Not the most common value, but the least common value. Isn't that the case then? If we flip that, 0 1 0 1 0 10. Perfect. Output, multiply oxygen generator rating by CO2 scrubber rating. Okay. CO2 times, what's the rating there? What do we keep that? Name that. Oxygen, hold on. Ooh. All right. So that's our oxygen rating, and that is our, let's call that CO2 rating, C02 rating. Oxygen rating times C02 rating. Expected use size. Cargo C into. Wait, why are these like U8s? Oh, I see. We're saying collect here, CO2 nums, and then we're doing like a right-hand fold here, use size, 0 use size. Does that work? No, that doesn't. Oh, no. As use size. All right, once more. Or test, run test. It passed. All right, let's get rid of our debugs. So we can undo that. Remove debug. Okay, cool. Run test once more. Yeah, that's good. Cool. Okay, let's run it with the input. Run. Oh, hold on. There's like stray debug somewhere else. Yeah, we overflowed. Thread main, panic that, multiply with overflow. Yeah, that is because here we need to do as use size. As use size. And we can remove that, right? There. There. Okay. Cargo run once more. Broken. Oh, no, it's not broken. We just get a warning. All right, that works. Output 2, 5069. It's not the right answer. Oh no. What's going on? It might overflow though. Yeah. Day 3, output 2. Parse 2 input. Wait, are our tests still passing? First check. Oh, we weren't like testing that. We should have been testing this. Okay, so that does pass. Hold on. So what's our issue? Are we overflowing? No, we're not. Cargo run. All right, so that keeps producing that output. CO2 rating as use size. Oxygen rating as use size. Individual counts are bigger than 255 in real input. Individual counts. Are we just like overflowing? No, what's going on? I said like time box it to 10 minutes, but we're so close. CO2 and oxygen are larger than 255. Yeah, actually, like let me like run debug on these two. Oh. No. Error. One 37 and 37. Is that the issue? Let's take a look. Oh, you mean like that? So if we look at the 3 out text. Yeah, okay. I see. Where's our U8? Is this day 3? No. U16. U16. Please work. Or, you know, U64. U64. Does this change our answer? It very much does. Does this break our test? It very much does not. Okay, sick. So I think it might be this. That is also not the right answer. Please wait for 1 minute. Easier to change the use size in the beginning altogether. Wrong output. Oh, whoops. Yep. Hold on. Return to day 3. Okay. Thank you. Thanks, everyone. I should have known to remove this. And you're right. I should just change it to use size, because then we can like remove all those intermediate ones. And it's not bigger than U32 for sure. Slash U64. Where is it? U64. Oh. Okay. Yeah. All right. Do we have this? Access denied. But was it the same answer? Day 3, output 3. 4-2. Yes. All right, we have it. 2 hours, 25 minutes. Oh my God. All right, that was a slog. Is there still time to compare solutions? That won't be long. Yeah, sure. I'll like take a look. Hold on, I saw a few links. Let me scroll up. Yeah, I'll just spend the last couple minutes looking at how others like solve this, because I sure did not do a good job. Yeah, look at this. Much better. Way better. Like little debugging, like little main function. Yeah, that's nice. Epsilon rate. Good. Report numbits. Nice. We're getting the fromster parsing. And then what's this doing? So this is Siebelsen. Oh my God. Thanks, everyone. Yeah. Look at how much nicer this solution is. It's like, in terms of like density, it's like way more condensed. It's got the little Tessie thing going on, report values going on. I mean, my brain is too fried to like properly parse anything. I can like look at the shape of the code and that's about it. Yeah. Yeah, exactly. First make it work. I got like way too ambitious with the first one where I was like, oh yeah, let me just do like bit shifting. I want to like do bit shifting stuff. And it's like, no, wrong move. Rejected. Yeah. Oh, here's like a Java version. The aux version did the trick. Most common volume position is used in all parts. Hold on. Most common volume position. So this report values I see. Oh, so it takes like a vec of, or like a slice of use sizes and says like, hey, for this position, give me like the most common value. Yeah, we like hand wrote this 12 times. Right? No, this is way better. We should have had this. Yeah, if we're looking here, it's like we are like repeating this all over the place. This is like not properly factored, but hey, it works. Yeah, it's way nicer. Let's see what the Java impl has. If anyone else like wants to share their impl, like please do. Oh my God, like 80 lines. It's got little getters. Oh, I didn't know Java had getter, add getter. I thought it was like only functions. How does that work? So there's a O2 getter. Get O2. .get. Entries get 0. O2. Oh, O2. Rating.co2. Oh, so that's like a straight getter. Is that? Yeah, rating.co2. Rating.o2. I see. Final by function. Okay. So IO utils, read lines, power consumption, rate. This is much nicer. This feels like someone who like properly had an idea of like what to do and felt comfortable doing it, which was like not me. But hey, you can't get better at something if you like don't try, even though, you know, we really tried on this one. I'm super grateful for Sai like helping me out, and chat like, oh my God. Another one tomorrow, I guess. Hopefully, you know, like another half hour and like 2.5 hours again. All right, I'm gonna lie down or something, or like have breakfast. Thanks everyone. I'll push this to GitHub in a bit, and you can like look at this monster of a thing later. Hope y'all have like a good day. I'm gonna start work proper in a bit. All right. Thanks everyone. See y'all tomorrow, hopefully.